Sound test. Right, I think it's all working properly. Hi chat. We get back to preparing some problems in Polygon. Last week, during a stream, I got back to Gaussian Elimination lecture. And not here on my wiki. There is this page I forgot about a week ago, Gaussian Elimination lecture, but there's also notes for lectures. And we started, but only started preparing some problems. I need to log in. I think the first problem is just you're given a very small system of equations, solve it using real values. And last time Polygon stopped working, so let's see how much of the statement survived. I think everything. We got the solution statement. I think last time I hit in HTML and then it all stopped working. Hi chat. In Chinese remainder theorem something. Just put your question in comments, I guess. Yes, you can do it in logarithmic time. I'm sure that I said something about it in the video. That I'm providing a very simple method, not the most efficient one. It was more of a math video rather than competitive programming. No, I didn't do anything since the last week. What do we have here? Given a system of equations and variables. Okay, you're given this. Guaranteed that maybe the wording should be find the one solution. It's guaranteed that only one exists. It's guaranteed. Yeah, I don't like the wording of this statement. +1 real values. Can we at most 3 digits after the decimal? Print values of n variables, 1 per line. Allowed relative or absolute error is this. And as I said, maybe we should modify it. Yeah, but this is looking alright. Just let's change the wording of this and let's choose the sample test or sample tests. What else? Validator. We for sure need validators, but I will get some help, and this easy stuff like creating a validator for a problem, I will just, I will tell somebody else to do it. But I want to choose a good sample test. Though that might be related to just preparing a lecture completely. How to practice for CodeGem? Solve Google CodeGem past problems. You can also guess how to practice, for example, for National Olympiad or IOI or ICPC. Solve past problems. How to get better code forces rating. Solve code forces problems. Alright, now do I want to continue here or just create the next problem? Notes for lectures. So last week I typed all of that, but a year ago I created this. Solve a system of n equations and n variables. Exactly one solution. Yeah, so I don't like 50 here. System of n equations modulo p. Save there 0, 1. Number of possible XORs. Python might be too slow. Find max XOR. Okay, find max XOR is too complicated. What we want to require is maybe first just say how many solutions there are. Modulo 1,000,000,007. Let's merge this. Let's move all of that here because this will be better. So XOR maximization is a good next problem. Even small directed graph. This is, I think, a topic for some kind of next lecture. Zero XOR subset. Split into segments. And doesn't exist a non-empty subset of segments. Okay, this is related to prefix XORs. And there are some harder problems. Insert and remove element X. Hulog cubic with a segment. Alright, yeah. I thought that it's segmentary. To do, check out this list of problems. Sorted by difficulty, I see. System of linear equations. Will it just be solve a system of linear equations? Do we need to print what happens one by one? No, we just need to print the solution. We're using fractions. How big the input is? Less than or equal to 0. From 0 to 50. N is from 0 to 50. It seems... Actually, maybe this is a good practice problem where you implement a fraction struct. That being said, you don't know how big the values can become. But maybe it's a good problem too. Do everything using fractions. Now, I guess it's kind of independent from everything else. It's a good practice to know how to use fractions to create your own struct or to import something in Python. But it's not really that you understand the whole algorithm better. Inverse square root trick quake free. I watched it. It's cool. Right. What is a good example? Let's experiment with that. I'm trying to use different version of OneNote recently. And it can do this very nicely. I didn't expect that. I'm gonna grab my drawing tablet. The plan for today, by the way, isn't something very particular, like to finish all the problems or something. It's just to work on this set of problems for Gaussian elimination lecture. Okay, what's a good example? We can start with something of size 2 maybe. Should it be integer or not? Let's see. 2x plus 5 is 7. I'm here taking random-ish values. It's not plus 5, plus 5y. And here 3x minus y is 1. Let's try to get this one. Then focus on this, and using it, get rid of this part. So second equation, we say minus equal the first equation times 3 half. But then it will be complicated with this 5. I should just decrease the 5. To what? Do I want to make it this integer or not? Let's make it non-integer, but small. This will be just y. And here something divisible by 2 for convenience. say 4. So now we'll get the second equation will become, first rewrite the first equation, and then here we have 0 minus y minus 3/2 of this, so that's minus 5 y, that's equal 1 minus this times 1.5. I think it's minus 5. Did I get an integer solution actually? Yeah, this is x is 1, y is 2. That was a little bit too easy. Maybe it's good to change something. I don't want to get integers by coincidence. Laptop keeps crashing for OneNote. Yeah, OneNote is not well developed. Sorry about that. What is the challenge? Yes, I'm preparing a problem on solving a system of equations, just like you see on the right. I don't like this right now because it's just too convenient. Right. What should we put here instead? What about 2? Oh no, I really wanted here a 3. Will this help to put here something else? No, it will not. Then let's go with, I don't know, 2y. But of course this can be simplified a lot, but we don't care. And what then do we get instead of that? Still this holds. So we have nothing minus y minus 3 of this, that's minus 4y, is equal minus 1.5 times this. That's minus 6, I think. So minus 5. Y is 5/4, or also 1.25. Oh, by the way, I'm sure that I'm covering some part of this. Oh, not a big part. You just missed this thing on the right, doesn't matter too much. Okay, and x is what? Oh, but I started solving it like a human would solve it. Instead, we should, so we can, I guess, say that, yeah, we can do this, but we don't really want to. And instead we have system of now those two equations, first and second, and now using this value, or using this whole expression, I want to make here a 0. This should become 0. And that shouldn't be too hard. First we say plus equal the other times 1/4. Yeah, so it is 2x plus 0 is equal 4 minus 5/4. This is 2.75. So x is, from this we can compute that x is, that was 16 minus 5, 11/4, 11/8 now, which is also equal to 1.375, I think. And yeah, y we had here. So the solution is this erased line and this erased line. I don't know if this is the best example we should do. I don't like the math. Use Cramer's rule, fill with 0 to complete square. This Cramer's rule. What the algorithm I'm using is called Gaussian elimination. So we are using something more general than this. This thing works only if there is exactly one solution. Well, determinant is hard to compute. Computing determinant actually requires running Gaussian elimination. Or finding inverse matrix. Algorithm for that is also kind of Gaussian elimination. So no, we are not doing this. How do you know when Gaussian elimination's precision is enough? You can run it and see what happens. It's enough for n up to 50, let's say, and values up to 50. It should be enough. Maybe not. Generally, the precision error can be exponential, so just if you deal with huge real values, like up to thousands or millions, then you cannot do this. But if it's very small, you can. Are we doing math or programming? That's intersection between them. Okay, I want a better example. So what's the solution here? The solution is integer, right? Yeah, I don't want integer one. On purpose, I'm creating something with no integer solution. Then let's do this. That's right. Do I need to erase this every time? Annoying stuff. What about we first choose what should be x and y? Maybe x is 1.5. So 3/2, and y is, what is y? Y can be -3, -4. Let's create two equations using that. Say 2x plus y is -7. No, this is -1. And 0x, no, that would be too easy. 4x, that's 6. Plus 3y, 6 minus 12 minus 6. Yeah, I think this example will be much better. So we use this to get rid of all other x's. And first equation I rewrite. And the second one is, I need to subtract half of the first one. It's 0 plus this minus half of y, so 2.5y, or 5/2, and this minus, no, I'm not correct. I'm subtracting the first one times 2. So it's more like y is equal to -6 minus this times 2. That's -4. And then we use it. So it's unfortunate, I would say, that here we got just y. It's too easy. Can I easily modify this? What can I put here? Maybe -y? It's an art to choose a good example, such that no two things will be, equal by coincidence and so on. 6 minus y, that's 10. Now we have -3y is equal to, again, that's second equation minus first one times 2, 12. And now we use this to fix that. And yes, right here we could divide both sides by 3 or -3, but we're not doing it now. So we say first equation plus equal second times 1/3 minus 1 plus equal second one plus third. That's minus 1 plus 4, that's 3. That's not right. 3 times, I'm doing something wrong. What am I doing wrong? My internet speed? I don't know, few hundred megabits. Oh, it is correct. I wanted to say that this doesn't satisfy our the very first text, but that's not true. All right, and from this we can get every x and every y. I suggest that we go with this in the lecture. We first talk about this example, and from this we get that, well, all right, x is 1.5, y is minus 4. Of course, you know, this is hidden, like they don't know it first. We just start with this, and then we eventually get to the solution in green. We got here multiplication by 1/3, so that's nice. All right, and I can say that, yes, a human would solve this differently, most likely, because we would first add both equations, and we would say immediately that 6x is equal to 9, but we want something very regular and well structured, so instead we do something else. Then the next example would be on 3 equations, I think. Guaranteed to have solution, infinity case can be handled by checking determinant equal to 0. But tell me, how do we compute determinant? Well, for n up to 5 we can just we can go through all the permutations. So in n factorial it's easy to compute determinant. Isn't there a over b is c over d? I don't know what you mean. We have here 2, 1 minus 1, 4 minus 1, 10. Then let's put that in statement. I mean in explanation. 2x plus y is minus 1, 4x minus y is 10. Should I in sample nodes to do n equal to 3 case? Should I in sample nodes show the solution? Maybe here just let's say the first sample test describes the following system of equation, and the solution is x equal to this, y equal to that. System of equations with a solution. X is this, minus 4. There is a ratio check for infinite solution case. Maybe for n equal to 2, not for anything bigger. And yeah, like you would need to consider all 6 numbers to say if there is a solution or not. Or actually, if there is same ratio between them, then depending on whether they number also have those numbers have the same ratio, you can say if there is 0 cases or infinite number of them. So I think what you're talking about is something like 2x plus y is, let's say, plus 3y is equal something, and then 4x plus 6y is equal something else. If we can see that this is double, second equation is double the first one. So if this matches on the right, like -7 and -14, right now we have infinite number of solutions, or maybe an infinite amount of solutions. And if we have anything else, like here 10, no, this is not, 10 is not double of -7, so there are 0 solutions. But anyway, that's only for n up to n equal to 2. Bigger cases are more complicated. Am I using Gauss-Jordan elimination? I don't know. Is there any other kind of Gauss elimination? We want to, well, in the case where there is one solution, and equations and variables, we want to get the main diagonal to be non-zero and everything else will be 0. If that's called Gauss-Jordan elimination, then yes, I'm doing Gauss-Jordan elimination. The first sample test describes the following system of equations with a solution, this and that. Good enough. Then we need to choose something as n equal to 3. And again, I'm also making that to, is that it? 2, 1, yeah, this is fine. Maybe I should take my code and modify it so it would print partial steps. I know what I want. I want such a case that in the second column it will be harder to find non-zero. Or maybe what we should do is to make it already the very first column. Let's say that the first equation is -2y plus z is 0, and then we have 3x plus y plus z is equal 1. I don't know, this. Because this time you shouldn't just say that you take this number because it doesn't exist. This is 0. So instead we take this one. Yeah, I think this might be easier and better. Then the first thing we do is say we take this one minus equal the second equation. Let's see how it changes. Then x gets erased, minus y, minus 1.5y, same with z, and this is minus half. This is how the last equation was transformed. Maybe we should make it the other way around. So to make it double instead of this, there will be more integers, it's then easier to compute. This is 3, this is 6. Then we say third equation minus equal second times 2. So it's minus 3y minus 3z is equal minus 2. This is the third equation now. In the second, and this was the old version, so let's forget about for a moment. Next step, in the second column we are looking for any non-zero, and it cannot be here. This one we cannot take, but we can take this one. And using it we get rid of those values. Sounds like a fine example to me. But okay, we want to finish it. So second equation minus equal first times half, or plus equal. I will rewrite the first one. Then in second one, 3x here 0, then z plus half of z, and half of 0 is 0. That's the second equation. The last one, this, no, that's most complicated, minus equal this times 1.5. So y gets erased, and then minus 3z minus this times 1.5. I think it's 4.5. This z is equal to, and here just minus 2 because we multiplied by 0. And the special terms so far are this one, and finally we need to take this one. We cannot use this. I will show it during the lecture. If we took this one to get rid of everything else in this column, we would create unnecessary y's. No, instead we need to take this guy. And this one gets annoying now, because we need to say 2 over 9 plus times something. What can you do? Maybe in a different color. Minus 2y minus this times 2 over 9 minus this times 2 over 9. Okay, this, then 3x is equal to times 3, no, times 1/3. So we have 1 minus 1/3 of this. 1 plus 2/3. I think 5 over 3. And yeah, we have the last line. And from this we get some x, y, z. To check this, let's again plug it into Wolfram Alpha, the initial system of equations. Hi chat. Let's see. I messed up, didn't I? This should be 1 over 9. That is, and this should be plus 4 over 9. Everything needs to be positive. So I messed up. Let's see if here I'm correct or not. If x is, okay, what about z? 4 over 9, yeah, already this equation is wrong. What about this? Minus 3 times y plus z, this is 2/3, y plus z, minus 2. This equation is correct. So from this to get that, we were fine. But then I messed up something when I moved there. The third equation is not that. What did I need to do? I needed to say, I have this, minus equal, this times 1.5. Then it's 4.5 z. Not, I don't know what I did wrong. Oh, because I need to say this minus equal 2 times 3 over it. So here I get something like 3. Yeah. This equation minus equal 2/3 over this one. So minus equal 2/3 of this, that's plus equal 2/3 of that, plus equal to z. So I should get 3z on the left. And I I have minus, this doesn't do anything for us, so I just have -2. So is it true? Do I have z is equal -2/3? That can't be. Because I think Wolfram Alpha told us that everything is positive. Okay. This is OneNote 2016, so it's also OneNote, just a different one. I don't like this example at all. I don't even want to get it right till the end. The fact that I'm struggling with it means that it's too hard. It's too hard to be used as an example in any kind of lecture. Let's just go with something as easy as possible. I have 2y. Maybe this is better. First step, use this term to get rid of all other x's. We say third equation minus equals second. So third equation changes into, let's just do it properly. So I will rewrite the first two. Minus y plus z is 0. And now third one. X is removed, y plus 2z is 1. Then, and let's say that this is still blue. I then choose that guy to get rid of everything else in this column. I rewrite the first equation, then second equation plus equal first, plus 0 plus 2z is 1, and same with third, plus equal first. So y plus 3z is 1. Still, this is blue, and finally I need to say that this is blue. First minus equal third times 1/3. Again, minus equal third times, this time 2/3. And 3z is still 1. Is this a proper solution? So, of course, from this we get that z is 1/3. And y is 1/3. Is everything 1/3? Yes, everything is 1/3. It's a bad example because if you mess something, like if you swap some stuff around, it's not good that that you get the same answer. So I would want to change it just very slightly to avoid this equality of everything. How old are Ericto? It's a funny question because it's in plural. Like Ericto is some kind of race, an ancient race of programmers. If I just change, I don't know, this a little bit, will it be fine? I didn't touch 3z until the very end, did I? Let's try to modify it a little bit. What if here I put 2? Okay, then let's just erase this and put here a 2. Then when I say third equation minus equal second, here I just get z. And then what happened next? I use this minus y. So I say this plus equal the last one. So this is now in red too, after correction. And I need to say okay, now I'm using this. So I will do first equation minus equal half of the last one. Then minus equal the last one, and that is half. I mean, this is what we get at the end. And of course, from this we get y is half, z is half. Right, right, right. Okay, cool. Yeah, I like this one a lot. This is the second example we are going with. Married with my computer. I didn't know you think of me that low. If you think my personality is that boring for the opposite sex, for females, that's sad. Right, I want to rewrite that. Zero minus 1 1 0 1 1 1 1 1 2 2 2, and yes, we use it as a sample test. So here comes this second one. A compliment? I don't want such compliments. 0 half half, good. Still, y and z are in the same position, but it's not that bad. Previously they were all the same. So if you print 3 times x, then you would by coincidence be correct. I don't want that. Second sample test corresponds to the following. Minus y plus z is 0. That. Okay, cool. I think we're done here with samples. And yes, I always spend like half an hour at least just choosing samples. Same goes for videos and lectures. Streams help to know me a little bit better. Sure, that I guess you have a lot of interaction in streams. It's different than just writing posts or something. Floats? Oh, good point. Good point. Damn it, I don't know. I will not modify the second equation. I will just modify the first one. Yeah, I need to put some floats here. Then let's try to create something with solution of x equal to 1/3 and y equal to -1. Then the equations are 3x plus y is 0, maybe plus 2y minus 1, but now it's getting complicated. I cannot in the input include something like 0.66. So nope. My rank in lead code? I don't know, but you can check. My nickname is the same everywhere. Or let's just get something here like, I don't know, 3x plus 1.7y, but it would be so arbitrary. What solution do we want? Let's say that y is 1 and x is half. But then the ratio, partial ratio, will be crazy. Give me a good system of equations with n equal to 2 and some non-integers, but so that it would still be easy to simulate this on piece of paper. We can sub because I'm not a Twitch partner. By the way, with this new OneNote, or actually the old one, I switched to previous version of OneNote because the new one was more annoying. First thing is I can type anywhere in white. Previously the issue was that by default it was black font and I needed to change every time. So that's one thing. And the other is that I think I could achieve the same in the other OneNote. On my drawing tablet I made buttons to switch between colors. And I also have now eraser just in my pen. I don't need to click anything for that. I mean, I don't need to click anything extra. That's very convenient. Anything special about elimination? Yes. Did anybody say that it's special? I don't think that it's a special algorithm. What's the name of program you're using to draw? OneNote. Right. 2x plus 2y is equal 1.5 plus 4, 5.5. And then 0x, or let's say again 2x. No, I don't want this to be exactly the same. Using this I will get rid of that part, so it can be like 4x. This is 3 plus 1, 4. I think this is better. And now we use this to get rid of the other x. So we say minus equal the first equation times 2. I rewrite the first equation. And then we have 0 plus this minus 4 times y. So that's minus 3.5 times y. And 4 minus twice 5.5, that's 4 minus 11, minus 7. And now this will be a trickier step. Because using this we need to get rid of the other y. So the ratio with which we subtract is crazy. I need to say that first plus equal second times 3.5 divided by 2. No, the other way around. 2 divided by 3.5. times second equation. And another way to write this is 4 divided by 7. What do we get then? 2x plus 0 is equal 5.5 plus 4, no, minus 4. That isn't 5 times 5, it's 5.5. Minus 4, and that's 1.5. And minus 3.5 y is equal minus 7. So now if you finish at the end of your program, if you print the matrix, it will contain values 2, 0, and 1.5, and then 0, minus 3.5, and minus 7. Right, and from this we can get y and x. Y is 2, x is 0.75. Yep, this is good. I see that Timothy Green typed something, so some proposed system of equations, or what is that? Water? I don't have water, I have some kind of yogurt. Yeah, so let's replace the first example with this. 2 to 5.5, 4 half 4. 2 to 5.5. Can I just have it on the side? And the solution should be 0.75 and 2. Yes, that's all right. I need to modify explanation. And a solution. Following system of equations with a solution that 2x plus 2y is 5.5, 4x plus half times y. Should I remove this dot? I don't know, maybe. It's 4, alright, and for 2 this is 1, this is 3, so the sum is 4, yeah, everything seems fine. And we got non-integers. Cool. Timothy, you are a bit late to suggest something because now I already went through this. I like everything here. Your example seems similar? I don't know. Actually, no. You didn't propose a system of equations. You only gave me one equation and a solution. So I don't know. Or maybe it was when I wrote down this and then I needed the second one. Anyway, this is fine right now. Maybe I don't like this, that there are so many digits 5. In case of inconsistent system, I don't understand the question. But in this problem, we assume that there is exactly one solution. I think that's it. Maybe let's think about the wording of this. You're given a system of n equations and variables which has exactly one solution. It's guaranteed. There is exactly one solution and you need to find it. Maybe this is more natural. Should I use it's guaranteed? Maybe I will repeat it in input form, in input section. Or in the output section. It's kind of short for this given system of equations has exactly one solution. Did he already explain how to prove the relative error of this? I'm not going to prove it. How many proofs of error did you see? Like, it's so rare. When you print, let's say you need to print what's the result of division, a divided by b. And you need to, the allowed error is at most 10 to minus 9th. Did you see a proof for that? It's very hard, and I don't know how to prove that. Even more, I'm not 100% sure that there doesn't exist a test where this fails. It's guaranteed that it exists, or there is exactly. You mean it's guaranteed that there is exactly? But then it's strange to say it's guaranteed that there is exactly one solution and you need to find it. It's guaranteed that you need to find a solution. Oh, come on. No. Polygon is down again. Are there other ways to solve this? I remember Kramer. Kramer anyway requires determinant, which is not easier to compute. Yeah, it's guaranteed that you need to find a solution. I will just write that in every statement. Well, that's annoying. Next time when Polygon works, I need to commit the stuff I already have. Okay, login. Why did it log me out? It's loading. Still. I wonder if Mike eventually will release Polygon as some kind of open source. Polish Olympiad maybe would use Polygon if we could run our own instance. Otherwise, it's very scary to prepare a big competition with Polygon. Polygon is amazing, it beats any other tools, but you know, a day before a competition, you realize about some issue and then Polygon starts working so slowly and you cannot do anything. And if it's on your servers, then actually there will be more issues, I'm sure, but at least you can do something about it. IOI got from Mike their own instance of Polygon. Ethical hacking. I heard that term. Yeah, so Polygon right now works very, very slowly. And let's take a look at the other problems I was going to prepare. modulo p, and this time n and m, they can be different. Some of them can of course be the same. We need to prepare samples for that. Modulo p, does it matter? Yeah, actually, there was some kind of to-do here, or maybe not. Was there? Maybe here. Think, does the answer always exist modulo p? And an example was where x should be equal to 5 over p, and then the inverse of p doesn't exist modulo p. Right. Yeah, modulo p, it's very easy to come up with. Even without modulo p, it's very easy to come up with system of equations with 0 solutions. You just need to create 2 solutions that are like, they don't work together. Maybe not trivially. I think good example of that is this. View, height, title. Oh, why is it blocked? Oh, because I marked it. Yeah, so 0 solutions we'll get for something like this. Say x plus y plus z is 5. X plus y plus z, or double that. Let's say 6, or anything else, 4. Unless 4 is double of 5 in this system of equations. I mean, in this ring, modulo p. Not ring, in this field, modulo p. This is 0 solutions. What else has 0 solutions? Something less trivial. X plus y plus z is 5. X plus 2y plus z is 5. So y for sure is 0, but then we have, I don't know, 3y is equal 7. Then also we have 0 solutions, because from first 2 you can get that y must be 0. For one equation we can even get something from the previous problem. But what about, actually maybe this problem is bad. What if I say 2y is equal something? Oh, but prime will be, I mean modulo will be prime. Then it works. Is it true that for any prime p there exists exactly one inverse? Yeah, I think it does. It is true. So this has one solution, then fine. Okay. And infinite amount of solutions. Well, that's if 2 equations are redundant, for example. But it shouldn't be enough to compare n with m. Every residue has inverse modulo prime. Oh yeah, that's then unique. Then still it's a good problem. How is Polygon doing? It may be better. That there is exactly solution task is to find it. Yeah, then we are done here. Still, there needs to be more tests. There needs to be a validator, but I hope I will get somebody else to do it. So the main, do I have more than one solution right now? No. Statement, samples, one solution. Never, in my opinion, never mark this in Polygon. You want to notify other people working on the problem about a commit so that they could also read the commit if necessary. Like check the diff. This was Gauss on real values. Now we need the same thing on integers modulo p. Let's do some coding. And I need to log into Polygon in my main account, create some second problem, or maybe even two right now, and give access to this fake account. This is dummy account, the one you're looking at right now, because I don't want to show you my whole list of problems. Let me not this. No. New problem, and this is Gauss modulo. What will be the third problem for us to do? Number of XORs. So that's Gauss binary, let's say. I will just make a contest out of this. And then I can easily just give access to everything in the contest. Right access. I think it's done. Let's see, view problems. Yes, it's all done. Great. Gauss module and Gauss binary. We'll do some copy pasting of the statement. Given a system of n equations and m variables, check if there is 0, 1, or more than 1 solutions modulo p. Maybe here I should say given system of this along with a prime p. Also given a system of equations, you're also given a prime p. Check if there is 0, 1 or more solutions modulo p. Maybe I should say there are. there is 0, there are 0, 1 or more solutions. Somebody speaking English, please help me. How did we get from Gauss to Chinese remainder theorem? What was going on? I mean, Chinese remainder theorem is easier. Oh, because I was writing this thing with Modulo. Yeah, just running Gaussian elimination on like Modulo P. It is strictly harder than Chinese remainder theorem. Find the number of solutions. But what I mean is you shouldn't print a value, an integer, the number of solutions. Or maybe you should. Oh, this is actually ambiguous, damn it. So I don't want to say find the number of solutions because I don't want them to print 5, 10, and so on. In the next problem, they will do that. Or more solutions, Modulo P. The system is Modulo P. How do we say that? All equations are taken Modulo P. And equations Modulo P. Is this how I can describe it? And now I can say there are n equations and m variables. You're given a system of equations Modulo P. There are n equations and m variables. Check if there is 0, 1 or more solutions Modulo P. Check if there is 0, 1, so it's R. 0, 1, oh yeah, this comma before the last element of a list. I don't think it's that obvious. Or more solutions to the system of equations. Thank you, Oquin. Let's see. You're given a system of equations Modulo P. There are n equations and m variables. Check if there are 0, 1 or more solutions to the system of equations. Maybe I should remove the first paragraph and just say here lowercase. What about just saying this and then in input we will say n and m. Check if there are 0, 1 or more solutions to the system of equations Modulo P. I like this statement more. We need a name as well. What was the previous name? Equations. What about just putting proper title and just saying that it's Gauss? Gauss. Can we say Gauss? Do they ever say Gauss? Gauss elimination. But maybe just Google that phrased it like this, called Gauss-Jordan elimination. Real value Gauss, can I call it like that? What was there previously? Can you tell how I started? I did math and then I did programming. Given a system of n equations and m variables Modulo P. Oh, I didn't say that there is P is prime. P is prime. I think that's enough. And then here I will just say Gauss modulo P. And then maybe Gauss on real values. Let's call it Gaussian elimination. Then Gauss modulo P and so on. Yeah, that's fine. Limac tries Gauss. I don't want to bother making educational problems twice longer just because I want to put Limac there. First line contains okay, now how many there will be? Up to 50? 100? I need to say what they are. Those are the number of equations and variables. Respectively, but everybody will figure it out. The if of the following n lines contains n plus 1 integers. Up to n plus 1. 3 integers actually, because there's also p. Can p be 0? Can p be 2? Do I mind? I don't think I mind. Equation, the number of variables, and the prime modulo value. They describe a single equation. Okay. Again with at most. This time we don't have any precision after the decimal, and instead we need to say that this is up to p. And close brackets. And p. Single equation. If needed, I will modify this problem to contain test cases, but whenever possible, it's better to avoid it. Oh, I don't want to leave this sentence. Exactly one solution, so the correct algorithm is to just print one. What do we print? Do we print a word, 0, 1, like 0, 1, or a lot, many? What do we print? Answer in a single line. Print 0 or 1 or -1. Would be better if you used this. I thought about it before. I agree that when I say x, y, and dots, it's not obvious what is happening, but I think it will be easier for people. I agree that formally we should say x1, x2 up to xm, but this problem will be attached to a lecture, and in the lecture I will keep talking about variables like x, y, and z. Or x, y are variables. Maybe, Brett, you're right. Maybe. But isn't that obvious? Print 0 or 1 or you think -1? Then of course I need to explain that -1 corresponds to a lot. I thought that it will format it in some way. Let's think about the variables. They describe a single equation. This times x times y. Nah. I will leave it as like it is. I think it's better. It's better to keep it simpler, even though right now it's not formal. After all, it's not a contest problem. Print 0, 0 or 1. Print the number of solutions 0 or 1, or print -1 if there is more than one solution, if there are at least 2 solutions. Does it work? Many for the last case looks good. You won't have to explain the output format. Keeps it simple. None, one, and I don't know made, but I saw at least 2. Maybe. We could actually tell people to print at least one solution. Maybe that's educational. Didn't I have an idea for this somewhere in notes? And this is the thing from a week ago. I had it here. Real values, count solutions, and print any solution where no variable is 0. Later we will have something with printing any solution. Right now just whoever prints maximum solution under time limit gets accepted. An optimization problem, I see. Print the number of solutions or okay, let's leave it like this. I want number in the output. Maybe this should be reformatted as text. Right now this minus is so long. Let's see if I put it instead of text ttt. Maybe I should put it in some kind of quotes. Yeah, -1 looks better. So let's put all those output values in text brackets. Print the number of solutions 0 or 1, or print -1 if there are at least 2 solutions. Right. 0, 0 or 0 for infinite number of solutions. I also considered printing 2, but I don't think that's good. The number of solutions 0, 1 or print -1. Right. And now the tests, or maybe first the solution. I don't remember what I have. Nope. In Genie, is there something confidential? No, it isn't confidential at all. It just code from last week. And where is it? Now YouTube code forces. This is Modulo. Should I just copy paste this to keep the style kind of consistent? Maybe. Well, we need division, so let's be done with it. Inverse. Maybe a function for multiplication as well. Yeah, it will be better to use it. Or do I just want to use longs all the way? Maybe not. Let's keep the style nice. Or we don't use longs unless it's necessary. So here we have few functions. Functions for operations modulo P. And then this time we have NMP. For every row, for every column, read it. And this should stay the same. For a column, choose the best row. Modulo is P. Yeah, I will here use... Oh, yeah, you're right. Normally I use modulo. This is why here I typed modulo automatically. Do I accept private training? Yes, but my lessons are expensive, so most likely you should just use free resources online, but you can write to me, of course. Just indeed, like Timothy said, must be divided by 2. Thank you. Okay, for every row, if not used, and best row is 1. Let's just say if A of row column is not 0, break. We don't search for better pivot because there's no such thing. Just take any non-zero. Right, then we don't assert that. Oh, now I need to start thinking what's going on. Maybe modulo P I want to swap some rows around. If here best row is -1, it means that there's infinite number of solutions, or maybe there are 0 solutions. Uppercase P. Do I want? Then maybe let's just adjust P and make it lowercase. So yeah, if I ever wrote mod, I meant P. Drawing, please. When we have x plus 2y plus something is equal to 5, and then there's some other stuff, but nothing is there and nothing is here. Oh, I remember one more thing better about this one note. It understands pen pressure, so I can draw something very lightly, but then I can put my pen harder and then it will be, thicker. So it adjusts. I can draw like this, where let's say this is a small connection, and the new OneNote for Windows 10, that was the name, cannot do this. It's a small detail, but it helps. So, you know, I couldn't do it in the OneNote I used so far. And it's sad that Windows cannot make a proper software for drawing. I don't understand that. Yeah, so assuming that now there's nothing here below X, this is empty, like all zeros. Same with Y, all zeros. And then what does it mean? If there is any solution for the remaining part, then I can choose any Y, and for this I will adjust X. So there are at least P solutions. This doesn't mean infinite. Modulo P, there cannot be infinite number of solutions, because at most the number of possibilities is P to nth power. That's not infinite. But I think we should still continue. When there is a contradiction, I think I need to get to the very end, and I will get some solution. I think only if I get an equation like 0 is equal to 3. Count the number of pivots to get rank? You mean count the number of columns without a pivot? Then I agree. Yeah, so non-zero right hand side, and here just zeros, then no solution. No. I'm still learning my new colors. 0 solutions. Okay, but at least I understand something here. If best row is equal -1, skipped columns ++, continue. And I will count skipped columns. Otherwise, this row is this. This should mostly work. Here we should say that ratio is multiplication of this and the inverse of that. Or I should just say division. Can I divide by 0? What is this? Oh, yeah, this is the value I found, different than 0. Was the comment right here? No division by 0 because of this? Okay, then it follows from an assert. Fine. So ratio is divide. Actually, I will leave the inverse function. Inverse of a. I wanted to simplify stuff and get rid of one function, but this is how I always implement it. We have ratio, and now we have this. And this is a little bit tricky. I need to say this is myself minus ratio times this plus modulo. Right? No overflows? I think no overflows. And finally, divide is divided by that. With some contradictions. For every row, I need to check if it's full of zeros with non-zero on the right. Can I just do this? If not used, it is equal to A of this row and of M. Also, I need to check here everywhere, yeah, M. There are a lot of mistakes right now. Oh, this is scary. There are 0 solutions. Solutions. We can fill skipped columns. Maybe you should say skipped variables. Yeah, let's say skipped variables. Or is there a better word? Skipped, maybe like free variables. Okay, skipped is fine. You can assign some variables freely. And oh, and here I'm finding a solution. I don't want to find a solution. I just want to say print 1. And this would even find it. But whatever. This array was called used row. It's whether we have some blue circle in a row. Am I good? Any mistakes do you see? Microsoft Whiteboard? I think I tried. No, OneNotes are better because of stuff like this, where I can move it around. So yeah, ability to modify stuff is much better. And sometimes I'm preparing a YouTube video, and that it's very important for me to prepare kind of interactive slides. Should be inverse of B in divide. Oh. Right now this would always return 1 unless A was 0, then it would return 0. Very useful function. Thank you, Maxim. Now it would be nice to test this. Let's do some testing. Or will I have people for that? Let's do some testing. I need an exponential solution that will try all the possibilities. And to make it very different from the previous one, let's do this. If possible, you should make brute force very, very different than the main solution. It helps avoiding same mistakes. Input is red. Maybe I want to make this global. I will have a recursive function that tries all the values. Let's say variable ID or something like that, which is basically column. Variable ID is equal to W, then we are done. Check if valid, and then return. But otherwise we say for every value. For this, starting from 0 up to modulo. Run recursion for the next variable. Okay, check if valid. Then yeah, I will make just everything global. And obviously I could make mistakes here, and with a few tests that I write by hand, it's very easy to miss something. This is why this is a good example of a problem where you need to have a very naive solution. And in this case, the complexity of my solution is p at power n, not at power m, the number of variables. It will check all possibilities for what variables are, and it will check if this is a proper solution for the given system of equations. All right, does this compile? X. There are that many, right? Right. For every row, check equation. For every variable, take a of row I, so the multiplier, with this variable. If sum is different than the last element, return. Then here it means that we checked all equations and we have equality everywhere. And what do I need now? I need a generator and some script. This generator uses test_lib already. I prefer to keep p small to make my solution fast, but it needs to be prime. I'm implementing it this way so that I could try also big P, but I will not run my exponential solution then. This is the best method to find primes. Just generate a random one and move up by one multiple times. It's still fast. The gaps between primes are small enough. So for values up to billion, this is a very good method. Right. Something of size w plus 1. Random value from 0 to p minus 1. And I think we have our random input. H and W. Oh yeah, we have N and M. N, M. Test_lib doesn't want us to use assert. We need to instead type in ensure, which is part of the library. Is this good? 417, give me some big test. This is a big test. 4 equations, 5 variables, and then there's 6th element. Cool. And now the script. We are comparing KDAC, this thing, and I'm compiling everything again with good compilation flags, so it would run fast. That was fast. Oh, print int. expo doesn't print anything. That makes sense. I didn't use any print. Switching to a more modern editor, what would I need in this more modern editor? I think for anything really useful that you tell me about a modern editor, I will give you one thing that it doesn't have, and Genie does. All right, I think we're good here. One more change I will make is to print the solution 0, 1 or -1. We have a lot of zeros and -1s, but there are some ones. Okay, so we have a good variety of tests. Nice. I will upload this generator to the website as well, so it would be there already, but eventually it needs to be modified to use bigger NMP, and also I'm sure that big random tests, they will tend to give one kind of answer. And for sure, I don't want this solution to pass. Let's call it W. No. A solution that just compares H with W. This is N and M. If there are more equations, then print, let's say 0. If there's equality, print 1. Else print -1, because there are a lot of solutions. For random tests, I won't be surprised if this works. Like for every random big test. Let's try this. I will use here values up to 50, and the prime will be big this time. And we are comparing the correct one with wrong one. Correct one with wrong one. Yeah, and let's run this for a long time. This time here, WA. You see? And this is why Codeforces rounds are often messed up. I wanted to use a different word here, not messed up. That they use random tests and then this kind of solution passes. This is our Gaussian elimination. I believe that what fixes an issue is to just use smaller primes, because then sometimes we'll get something non-obvious. And maybe I should also, I didn't expect that. My main solution failed. Huh. Sysmalloc. All right then, let's debug this. Oh, we already got the editor discussion in the chat. Why don't you use Vim with Genie? It's so broken. What do you mean with Genie? I don't know how to quit. I don't know how to exit from Vim. With Genie, it's very easy to close it. You know, competitive programming is very simple. I work with one file. In Genie, I have two buttons, F9 and F8. They do two different things. When I compile, I will have highlighted lines with an error. I don't know what else you want. How to output, capture output from program in Bash. best result. I usually for that Gupta just redirect it to some file like this one, and basically I run some other, I don't know, checker or something, and checker.cpp is just a C++ solution that when it gets something, it maybe works with files, it opens another file. So there is also best so far.txt, and it compares out with this one. I don't know, I only know a hacky solution to your question. In editor, real-time diagnostics to be super useful. It's true that I'm not good at debugging with, running step by step. And maybe another editor would help me. And Genie was available in various competitions, like, ICPC. All right, let's debug our KDAC. GTB GCD. Line 50. Which row of column? I think that yes, here, used row, which row? This should say M. It's slower because I compiled differently. After, as the 100th test, we got a counterexample, but instead we needed 100 random tests, and in code forces, or with some other parameters, by the way. If here in generator, I used, let's say, in the problem, n is up to 200 and m is up to 200, and I have this. I expect that we will have around 500 tests until we find a counterexample. 128, okay. We got lucky enough. Maybe with a bit bigger p, it will be even worse. I don't know, of course, it's estimating. 63, it's not that bad. But with small data, it will be instant. And on the other hand, with very big data, for third test, with very big data, it will be here infinite, and this program kind of becomes correct. Here it will pass thousands, if not billions of tests. Maybe not billions, but the bigger the p, the smaller probability is for some two values being true by coincidence. What's happening right now? I am showing you why your random tests are bad. And when you're organizing a code forces round, you shouldn't use only random tests, and that's it. And you should try stupid solutions like this one. If I don't properly choose parameters for my test generator, this is a solution that passes thousands of tests. And instead, this is a correct one, so it's a bit more complicated. Oh, and this would be a mistake, right? It would. Column is up to M. Good that I found this mistake. And also it suggests that it was dangerous to start with it. Maybe I should change the first problem, because people will first implement it for real values, n by n, and then they will struggle with switching to the next problem. That's bad. And on one hand, I already made a lot of work assuming that this is the case, that n is equal to m. Like I chose samples and then I will need to spend half an hour redoing that. But when you're preparing something for thousands of people that will spend each at least half an hour, maybe hours on it, then it's worth it for me to spend extra time to redo it. So would it be a little bit better if the first problem was actually not square in the input? Because I don't know. It was actually unusual that we had square, but otherwise there isn't exactly one solution. So there can be if multiple equations, they are linearly dependent. Like one is just double the other. Huh. Damn it. I think I will leave it like that, but it will make some people struggle, I guess. Then the only thing I can do is to say during a lecture, be careful with this n by n. Right, do I need to do anything else here locally? I guess it's time to upload this to Polygon. I wonder, is it now bad that you see the link I'm using, and now it tells me to open a link from email. If I now show you link from my email, is it bad? Can you enter it? And I still didn't get an email. Or maybe it's because I should switch to another email. So if I now open this thing in incognito mode, can I log in? I think I can't, so it's fine. I hope. I'm just trying to do it without showing you my email. And trying to, just understand it. Maybe just don't show us it. Thank you. That's a very good advice. Gauss Modulo. We are ready, I guess. Are those limits good? We have n cubic times logarithm coming from modular inverse. Will Python be fast enough with those limits? How much time will C++ need? We can check. Let's say that m is first argument, then p is whatever, it doesn't matter. (10 milliseconds). This is one of those moments where when I see that my program is enough and it is 100th of a second, then I think, okay, if somebody struggles with this in Python, they should just switch a language. But other languages can be 100 times slower than C++. But here it will be just about modular operations, so it shouldn't be the case. It's not that you use memory very slowly. So when doing multiplication and modulo, Python shouldn't be 100 times slower than C++. I think we're fine. The time limit will be 2 seconds, I guess. I hope this is not confidential, is it? Okay, it's fine. We have this, this, and that. Whoa, second thread is here. Whoa, whoa. Actually, a lot of strong guys visit my streams from time to time, and I'm very happy about it. And today we had second thread and Eknerwala. And Maxim. I don't know what Maxim that is. There are a lot of Maxims. Is there a very well-known Maxim? Maxim is just an ordinary name in Russian, also in Polish. Okay, that counts. So we had 3 strong people today. William Lin, he hasn't uploaded in a while. I don't know, I guess he's busy with MIT. Kickstart leaderboard, so he's alive. You know, I also didn't post on YouTube for a long time on the main YouTube channel. Videos take a lot of time and preparation, and a will to do them. We have solutions, tests. Before now, let's just put a generator here. Right now, this generator is messed up. What should I do here? Let's do that. So I will pass as arguments values of NMP. And what test do we need? It would be nice to get a nice test as a sample, but for now, just work in progress. Let's try something with 3, 4, and I don't know, 7. 2, 2, 5. All right, that's some start. See details below. What's wrong? Gen is invalid. Should I just type gen? I don't remember. Then there's button preview tests. So you would see what's generated and what are the answers. Checker not found. Single. Or I guess this. Maybe huge integer. So I told checker that it should just check if a good integer is in the input. Every output will be a single integer. There is also an option to just compare tokens, so strings. Why did we get 0 every time? I understand it here. Oh, so here it was just a coincidence. And here it was also a coincidence for 7? What's the probability of that? Yeah, actually, what's the probability of that? Given 2 vectors in 5 dimensions, what's the probability that the third vector will be linearly dependent from them? I think the probability is 1 over 7 cubic. Right? Because there are 7 square possible linear combinations of that. And here you have 7 to 5th power possibilities. Yes, it runs so in solutions, one program is marked main correct solution. Then in tests, this one is used to generate outputs. And I think here we got something with this probability, 2/3, or at least around that, which is 0.3%. I want to actually confirm it because I'm very surprised about what happened. So let's get test. I generated it like this. And I can try different seeds. And I claim that almost always the answer will be -1. I just want to try 100 values. $100 tests, all the answers were -1. 500. -1s all the way. $5,000. That's very suspicious. You wrote gen as the first argument. Okay. I think it didn't change anything. Yeah, gen is not correct, I agree. Now it's good? No, it's not good. I'm stupid. Okay, so how often do we get zeros? But this is why I'm investigating. Mistakes are perfectly fine, just whenever you see something suspicious, do investigate it. Among 100 tests, we got 3 zeros. I think it suggests that it's like 1 over 49 maybe. I thought it's 1 over 7 times 49, but maybe I was wrong. Anyway, this was very surprising, but yes, sure, it can happen. We can try another group of tests with different seeds. I expect that now something else will happen. Yeah, -1, 1. So those are the same parameters like here, just different seed. You can add in testlib any kind of string here, and it will be like everything here together is taken as a seed, or maybe even along with a name. I don't remember. I don't want to save this. Right, but I can run invocation to see how my programs do. So this failed, but it would pass big random tests, I think. And this test has big P, so that's why this program fails. All right, we didn't choose samples, but I can do that later. Or somebody else can do it. Solutions, statement, solutions, random tests. Maybe code is not compiled. I think everything was fine, just that 1 over 49 is reasonable then. But we got then an event that had 2% probability of happening. It's possible. But suspicious, and this is why I investigated. Then we have binary Gauss. Number of possible XORs of subsets of given n numbers. I wrote it twice even because I have two sets of nodes. All right, let's go with that. The statement will this time be different. Gauss modulo P. How do we call this? Count XORs. Are given count the number of distinct XORs you can get. Number of distinct values. XOR a subset of numbers of the given set, maybe something like that. You're given an integers, AI. Count the number of distinct values of XOR of a subset of given numbers. I guess more or less this is fine. Integer what will be the complexity? Square? Like n times log square or just log? I think it's just log if implemented properly, but do we want to require it? Maybe I should make two problems, one with quite small n, like, I don't know, 50,000 and big time limit, and the other will be much tighter. The limits will be. So I'm not sure to think about this limit. Count the number of distinct values of XOR of a subset of given numbers. Yeah, fine. Everything is in long type from 0 to 10 to 18th. That's it, I think, about input. Where's the link to your Gaussian Elimination GitHub file that you had just opened? Thank you, God Mode, for pasting. You can also go to my wiki on GitHub, and on the right in menu you will find it. Right. Oh, print the answer Modulo something, because it can be huge. I don't want to say that XORs are modulo billion7. Print the remainder modulo this of the number of possible XORs. Are you setting problems right now for Polygon? I'm using Polygon to create problems, yes. Remainder modulo billion7 of the number of possible XORs. Now, do we care about empty one? That's a good question. Maybe I should say among 2 to nth there are 2 to nth subsets of those numbers. Count the number of there are possible subsets. I like to clarify stuff like this just to help people avoid mistakes, like somebody will think that we just need to take interval. When you say that there are 2 to n possible subsets, you make sure that they understand. And it doesn't hurt too much to say that. It's not a lot of words. Remainder modulo beyond 7 of the number of possible XORs. I think this is good enough. Link inside the Wikipedia page of XOR. Oh. Okay, good question. No, I preferred Wikipedia. Exclusive OR. No, this is bitwise. Bitwise exclusive OR. It seems that maybe there is no article specifically for that. Count the number of distinct XOR is bitwise exclusive OR. But also, if somebody doesn't know what XOR is, they shouldn't try to solve this problem. XOR. And now the second bracket became like a little bit too much in this sentence. Bitwise operation XOR. I see I got 2 distinct links. The one is what I had, yeah. Okay, I like the one with bitwise operation and then XOR. It's fine that they have such 2 similar links. Refers to bitwise. How do you maybe in italic, the cursive, I think it's called. Let's see. No, text it. I messed up. Text it. Okay. Below, XOR refers to bitwise exclusive OR. I'm not sure about formatting. XOR refers to bitwise exclusive OR. And we want this to be a link, but I don't know right now how to make a link. To do make a link. Oh, it's here. URL. So you see, preparing problems is a lot about just formatting the statement. You're given an integer. Count the number of distinct values of XOR of a subset of given numbers. Print the answer modulo beyond 7. Maybe we should say what's the XOR of subset. So more than 2 numbers, but I think that will be in explanation for samples. The number of possible XORs. I think statement is fine. Since the answer is at most this, good point. Yeah, we don't need it. Thank you. Print the number of possible XORs. I thought that the number of is exponential, the answer I mean, but no, it's exponential, but there are 60 bits, so it's at most 2 to 60th power. Count the number of distinct values of XOR of a subset of given numbers. should I remove below? XOR refers to bitwise exclusive OR. I'm not sure. Time to implement something then. This is binary. And there will be slower and faster version, I guess. So the fast version just minimizes with a bunch of numbers from base. For everything already in base, we do this. And how many distinct stuff? It's just 2 at power base size. Right? Yeah, I think so. Apostrophe from XORs. Should I? If something is, you know, abbreviation of or this any kind of short format, don't we say apostrophe s at the end? It just this format is correct? XORs? Can somebody else confirm? Text link. So Timothy said that I can do something else here. Of XOR. What about here? Saying bitwise exclusive OR and putting a link. Let's see how this looks like then without the first paragraph. It didn't work. Should I say URL as well? No, well, the link was here. And maybe I need to type URL. Apostrophe is used for indicating ownership emo. Yeah, but not only, right? I thought that also, like, you use it when making plural out of something like this. It seems that this does not work. Okay, then for now, we'll leave it like this, and fine. The number of possible values of XOR. Here we go. Problem solved. XOR. So you're saying that this should go after the main paragraph? Number of distinct values of XOR of a subset of given numbers. Sure, I can put it below. No apostrophe. Okay, thank you, chat. The link didn't work? Yes, it did not. Oh, you mean the one from the chat? I can copy paste the whole link. So whenever I see this messed up link in the chat, I just mark the whole thing, copy paste it, and it works. We good? So that's this fast version, and then very slow one. Also, maybe it's time to do some nodes. This is n times log of value. Here we will have n times, I think, log square. Has to do shall brute force. Not to forget about this. But here I'm just implementing Gaussian elimination, but slower. Something that will more directly mimic what we had so far. Because the fact that this works is crazy and surprising. And here we will go through rows and columns, I guess. So for every next column, I will find some non-zero. I can, by the way, tell you what this means, what this solution does. When we minimize with something with base, it's like this. The base is rows that we already have. Like, let's say we have this one. The first one is always the one in blue circle. And maybe we also have this thing. This time we don't do the operation of saying previous is XOR this with new one. We just leave it like that. And now what happens when we get a new row and it's, let's say, like this? Well, we see here a 1, but we already have a 1 in blue circle here, so we XOR. We get this new row and we XOR it with the first row, this one. This is B in base because we iterate over stuff already in B. This is our X. And we get rid of this one by minimizing with XOR, with X XOR B. So then in this column we will get 0. And new X will be then what? 1 0 1 0 1 1. That's the new X. Then we minimize with XORing by this one, and we see, okay, right now I don't have a 1 here on this position, so I will not XOR. This line modifies X if and only if there is 1 on this in a column where there is already a blue circle. And this works for finding the base size. If you need to actually find a solution, then there's a little bit more work because you need to use the final X you have to simplify the previous rows as well. So here optional step is, I think, to iterate over things in base and minimize them with B XOR X. This gets, if X has some 1, the first one in X is blue circle right now, and you get rid of other ones in the same column. But we don't need this step. It's text link, but I think I already tried that as well. So do I need to type URL or not? Also, maybe it's messed up because it's in a bracket pair anyway. Test, no. So here I should use whatever, right? I think it just doesn't work. Incorrect command parameter. no URL, right? Didn't work. I would be surprised if no URL worked if this is what they require. One last try without brackets, without like outside brackets. Yeah, so it doesn't work. Ref. Like this. But first URL and then text. You're making this complicated. Okay, it worked. So now instead of text, I want to say bitwise exclusive or and close brackets. Count the number of distinct values of XOR in brackets bitwise exclusive or of a subset of given numbers. What operating system are you using? This is Linux here, Ubuntu, but also have Windows 10. Okay, so thank you chat for help with this. I'm not sure if this is the best possible statement, but it's short. Of XOR, bitwise exclusive OR, subset of given numbers, in brackets there are 2 to n possible subsets. Right. So here we just get the solution from previous codes. Do we then read everything? How to adjust the previous code so it would work online? And does it mean that this previous code I could do online as well? Difficulty level? I don't know. It requires knowing a particular algorithm, so you won't be able to figure that out if you don't know it. Then I don't know how to assign difficulty. Same thing, what's the difficulty of flows? Well, you need to know flows of a subset. I see, Gupta, what you're saying. Count the number of possible distinct values of XOR of a subset of given numbers. Maybe something like this. If you can choose any of 2 to n subsets of even numbers, what's the number of possible, how many distinct possible values? Can remove any elements. Well, but you don't get subset in the input, right? Count the number of distinct values of XOR. Okay, but distinct values of XOR you can get by taking a subset of given numbers. What about this? Of XOR you can get by taking a subset of given numbers. I think this is better. The stream will finish soon. And just a warning. So before I do this, when we have a solution for real values or for our in-field modulo P, can we also do it online by getting equation by equation? You're given first equation. You will kind of fix the leftmost variable. You will take it in blue circle. Drawings, please. No. Let's say actually that this is x doesn't exist, but you put this in circle, so you want to never touch it. And now we have some second equation given. You can use the previous blue circle to get rid of this one. It's not wrong. Then you put this in blue circle and here nothing bad is happening. What if instead we had this? Then you just put this in the circle. Then there are two questions. First is, do you already get rid of this z when looking at second equation? Actually, that's the only question I have, because later we will say this is in circle. And so yeah, I think that this z removed that stuff. And using y's and z's, we need to remove this as well. We need to change them to zeros. We shouldn't do this from the very beginning because we cannot choose pivot properly. This order has worse precision, but it's possible to do it. Like, we can do stuff this way. It's not bad. Let's see how CP algorithms does it. CP algorithms, Gaussian elimination. Modular. Yeah, let's read this. They swap some two rows. If it's 0, then continue. Okay, so they keep track of the current row. Wait, why XOR? This is not modular. What's going on? Oh, so, okay, they called it modular, but actually this is binary. For every column, there are 60 of them. Go for rows and find something. Here again, go through rows. This is n times single log, isn't it? I don't see 3 nested for loops. We have a swap, but it's done once. This seems to be n squared, but it's limited by m. So it's m times n. Also, it's just n times logarithm. Since when did you start learning programming? More than 10 years ago. Or actually 10 years ago, when I was 16. Or a little bit younger. Same as your code, they do the extra step too. this is the special column. They first find the blue circle in the first column, then they get rid of all other values in this column. Then they look at second column, they find some blue circle in rows where there is no blue circle so far, and then they get rid of all other values in this column. Sometimes they skip a column. This happens when there is no non-zero in some column other than already fixed rows. By fixed row I mean a row with already a blue circle. When specifically, what do I need to be that exact? It's answered here for sure. What about treating this more literally? For every column we go, okay, so this is the same. And I will try to mimic my old solution. Of course, we don't need functions to multiply modulo or anything like that. Which row for every column? Which row? Why do I need this? Oh yeah, I remember. So this is more like n log square. Wait, what's the complexity of Gaussian elimination? Is it n squared times m or n times m squared? Let's think about it by looking here. N times n, so that doesn't matter. N times n. Oh no, this is the one where everything is n. Never mind. M, n, m. So the complexity here is O of n times m squared. Well, times, do I have here? Oh, I don't divide there. So it's like this, plus nm times, right? Yeah, nm times I compute division. That's the complexity. And in binary version, we have here n log square, but we do XOR instead of iterating through something. So it's n log square divided by 32. So just n times logarithm. I think it's good to include everywhere the complexity. This is the real value. Did I type this correctly? Yeah, I think so. Gaussian elimination. Title and put complexity. Solution. Then in the modulo one, I also want that. The exponential, let's say that this is what around, it's not exactly this, but whatever, p at power n. Right, not the other way around. No. No, p at power m. times n times m, but that is not important. Maybe let's say that this is tle. I don't like the lack of space here. Okay, no. Everybody's OCD is cured. Spaces are put properly. Thank you everybody for following. Xtudor TV actually sounds like a bot, to be honest. Castu, 4ydini. Thank you guys. So back to the current one, so the binary problem, count X source. Oh, I need to change it in the title even. Oh no, I thought that here I'm fixing it. Count X source. Okay. It will be bad if the title is grammatically incorrect. Can you try this? No, I cannot. I'm busy, I'm doing something. After this tutorial, I expect Gaussian elimination problems in Codeforces. I think then it will be bad for them to use Gaussian elimination for a little bit. Like, if a topic was very recently covered in a blog, in Codeforces, for example, then coordinators will try to avoid this problem, at least postpone it. Because you reward too much a lot of people who just recently learned something. Similarly, you don't want to have two adjacent Codeforces rounds with very similar problems. If they're far away, it's fine. Some problems are similar, but not one after another. All right, we have solution files. So here. Wait, do I want to do it online or not? So this is online. This is offline, where I read everything. I think that here I need the speed up. Which row of M? Should I just type here 60? Well, I don't need that. Maybe I should leave it. But same in the previous problem. Did I use which row? Yeah, I didn't use it. So that's unnecessary there. But this I might need. Skipped variables, what does it mean? So the answer will be 2 at power skipped variables, right? Or not? No. Wait. What am I doing? This is slightly different because we don't say this, all of that is equal to 5. No, we just... maybe I need to think more about what I'm doing. I will read the blog after 2 months. Nice. That's very smart. Flows. I don't like flows and I don't like game theory. I also don't like graphs and strings. at least hard algorithms or graphs, and flows are included there. Trees are fine. Various algorithms for trees I know, like centroid decomposition, but in general for graphs, no. I'm fine with, I don't know, constructive algorithms, some math, but not number theory, combinatorics, probability, geometry. Did I leave here? Yeah, I left unnecessary comment. This is not right. This is any non-zero row. Okay, this is 2 modulo. There is some tool to connect Polygon to your terminal. I think it's by Paweł Kuniawski. I'm mispronouncing the surname. But this back and forth is very dangerous. We have second modulo problem. But because I want to make this educational, I care about comments here, because I will show people the solutions with comments. This is why I keep updating whenever I see that comments actually can be made better. In a code forces round, I wouldn't care that much. Is it a proper? Yeah, it's proper. Fine. Find any non-zero. Okay, and here this time I will cheat and not even send notification, just because there was just a comment in the code. I close that. Gauss modulo, and let's continue. Any non-zero in this column. Columns are up to 60. If not used, and column is a bit. Fine. If best row is -1, right, used row, yes, I need that, but I don't need you. Alternatively, we could swap. Do you see any advantage of swapping over what I'm doing, marking rows used? Won't you just do a row and this? Oh yeah, of course. This doesn't compile because it's one-dimensional array. Thanks. Now for every row, and if you have one, get rid of this one. And we don't need to do anything for past rows. I mean, for those that are already visited, but whatever. Can there be 0 solutions? No. Let's try some input. Say 1, 2, 4, 6. This is not correct. This looks correct. So the slow version printed something bad. Did I not? What's going on? All right. I thought that I have my templates with me. Let's print what the skipped variables is. 57. Because I'm not measuring skipped variables, am I? I think I'm measuring not skipped variables. Should I count the blue circles? Because for some column I'm marking here, actually, let's call it count used rows. This makes a lot of sense. The thing is that it counts rows with a blue circle, and each of them you can either use or not. Okay, I think we're good. Sonic Pi, I don't know what that is. Should we try generator, or do I assume that this is fine? Let's maybe create a good sample test. Should this be the main solution and this is extra? I think so. Well, I can as well implement the slow solution. It will take me a minute. Notice that I don't even copy paste the reading, just because I'm afraid that I will make the same mistake. Then it's extremely dangerous. I'm making this if because otherwise I might get wrong answer for big N, and I want to mark this solution as time limit exceeded. But on the other hand, I prefer faster judging whenever I resubmit. So let's say this, and I will mark it as time limit exceeded or time limit exceeded in Polygon, but this is not good style of creating Polygon problems. This is just for my convenience. In code forces around, you shouldn't do it. There is some danger to that. If you have slow solution, make it always either slow or working properly. Don't put extra asserts just because you want it to be faster. Did you know that you can call a set set? Let's submit all of that. No. Can we call a map? Yes, you can. Map can be called map. I am Portuguese, but I know a little English, right? I'm not sure if that's the best stream for you to watch. This is not main correct solution. This one is. No, the slow one. Main correct solution. This is time limit exceeded or... Oh, damn it. There isn't an option to say time limit exceeded or assert. Okay, then let's make it, let's do proper style hit. Otherwise you might miss the fact that something is wrong. There is a small test and it was wrong if I just mark it as incorrect. Otherwise Polygon tries to check that it's exactly this verdict. If I mark solution as time limit exceeded, it must be accepted or TLE on every test. Okay, chat, give me some tests. Just choose n equal to from 1 to 10 and print with spaces 10 variables, 10 values that will, you know, pass in those limits. Give me some tests. What did I already here have? This. I just want to see that the solutions agree with each other. Nothing more. How many qualified, how many numbers is there? Wait, why I cannot copy paste? There is 8. Okay, that will be enough. Thank you, everybody. Thank you, Random Dude, for an interesting test as well. 10. Seven. Didn't accept to test for no end line. It's not that it doesn't accept, it adds the end line automatically, so don't worry about it. Okay, is everything alright here? Checker not found. We have single huge integer. Sorry if I missed somebody. Later there will be validator anyway to check if, for example, there is some extra space, or maybe some n doesn't work, like it is 1 too big or too small. Now let's run solutions. Cool. That's some strange status. When I again clicked some the list, it again copy pasted the same message. Anyway, I added an issue. This is issues you can use as to do. Whenever you see that something needs to be done, I'm not putting there information that validator needs to be added, because Polygon, anyway, when you commit something, it warns you that, hey, you didn't add a validator. Highest level of math you have taken? 5. I almost got to IOI, so maybe that's the highest level. But also I studied math for a little bit later in University of Warsaw. Now, maybe the last thing for today. Let's choose sample tests. So we want maybe something with n equal to 3 where they are not the same. Okay. I want to create something with the XOR of everything is 0. An example of that is 5, 3, and 6. I think that they XOR to 0. Something with n equal to 2. Then samples should usually, oh, I can fix it automatically. Yes, please. Samples should usually go first. What about here putting 2 equal values? I think there should also be a test where things are 0. Maybe somebody will make an if and fail that. I'm not putting that in samples. Okay, so we have this and maybe one more random test. Do we have a random test here? I don't want to add this one. Oh, wait, was there double 9 there in the test? Why double 9s? Shouldn't it just be 69 for 20? This one looks random-ish. What's the answer to this one? 32. Okay, fine. I'm happy about this. In the first sample test, can get 4 XORs. And here's some kind of list where I will say what's possible. Zero, 3, 5, 6, just this. Combining 2. Or maybe, do I want to say this? Can't get any other value. I think that's enough. In the first sample test, we can get 4 different values of XOR. 0, 3, 5, 6. Like 3 XOR 6, that's 4. Isn't that 4? No, it's 5. Okay, everything is fine. Oof, I think we're done. IMO rather than... Oh, yeah, sorry. I wanted to say IMO. I was close to getting to IMO. Thoughts on AI? I don't know what is AGI, but AI is like, yeah, it just... We don't right now have really artificial intelligence. I would say. Like, sure, it's like those programs can do something, like drive a car if it's good weather, but you can automate a lot of stuff. So that's current AI. And the algorithms are very good. They can beat people in multiplying two numbers and also in playing chess. Can the number of subsets with given XOR? The number of subsets for any XOR is the same. That's a funny thing. So if you have, kind of because the ratios are the same. If you have, let's say, n equal to 7, and then there are that many subsets, and in some particular test you computed that there are 2 to 5 possible XORs. Then there will be 2 to 2nd like possibilities or subsets per XOR. Every XOR will have same number of subsets. So in this case, 4 subsets per XOR, just because the number of subsets is 4 times bigger than the number of XORs. To-dos in real life are rare? What are you talking about? Of course they are common. You see, there is a warning, no validator. If I go to list of problems, or even view contests and view this, there are issues listed here, warnings. Like when you want to publish a contest, you should get 0 warnings. And here the issue is no samples in problem 2. No validator in every problem. No tags here, no checker, because I didn't commit. What do we have? Statement, samples, solutions, random tests. Few small tests. Can bot be trained to participate in competitive programming, securing first rank? Not right now and not in the next 10 years. We are very far away from that. In particular, because the number of existing problems is too small. You need to train most ML bots or AI bots need to train on millions of items. Maybe thousands, I'm not sure. But the existing problem set in the world is maybe 30,000 problems, I don't know, maybe more. But a lot of that is not in English. A lot of that will have a very obscure statement. So no, that's just too little. Maybe if all of them were written in very simple English, then some AI would be able to solve simple problems. But then it would mainly just kind of guess it by looking at codes. So no. We are not close to AI doing competitive programming well. Get the job? I don't know, not my field. Maybe Python. Or some kind of Ruby? I have no idea. Alright, thank you everybody for watching. Hope you enjoyed this. I might do some extra streams about this preparation, so not necessarily 3 times a week, maybe a little bit more. If you do English, everything you need to know about max operation. That's an interesting video. Is this again? Oh, this is in English. The previous one was prefix sums, right? Yeah, so go check this out. I don't do this kind of style of videos because it's a lot of work and I don't think it's worth it. It's style of 3 blue, 1 brown, where you have animations. But well, it looks nice. So go watch it. You can find this on the main page of Codeforces. What am I making problems for? For my own lecture that will be published on YouTube/Codeforces. Alright, again, thanks for watching. Check out the Discord if you have suggestions, comments, and see you most likely on Thursday during a coding